Good morning.
Morning.
All right, folks, it's 8 o'clock. We'll get started. Can you all see my screen?
Yeah.
Yeah.
Yeah, thank you. All right, so we're getting on here to calculating the equilibrium constant. And the story with these is that you'll always get the concentration of the reactants. And somebody had a question about one of these, I think it was last week. I think it might have been you, Gabriella. Can't remember. But you were saying that you were confused about how many you were given. It depends on the number of reactants you have. In this case, we've got 2 reactants, and they both have the concentration of 1.000 molar. So the other thing we're going to be given here is the concentration of either a product or a reactant at equilibrium. So we've got the initial concentrations of reactants and then a concentration of a reactant or a product at equilibrium. Now, by having this data, we'll be able to calculate the equilibrium constant K for a reaction. Now, it doesn't matter about the temperature. That's not going to have any effect. Somebody needs to mute here. I'm not sure who it is. Okay. So let's look at how this goes. Now, the Z here is sometimes confusing to people, but here's what you've got to be aware of. If you've got a reaction and you're starting out with just SO2 and O2, then there's only one direction that those concentrations can go, and that's down. So we know that that's why these are minuses here, a minus here and a minus here. The other thing we're aware of is that the way the reaction goes is going to be consistent with what we're seeing for the coefficients. So that's why we've got 1.000 minus 2z and then minus z. And then over here, we've got 2z. So you can see that whatever's in front of the z matches whatever is in front of the actual substance that we're talking about, the coefficient. So let's look at how that works. So let's say we've got an initial concentration of things here. And you can see I've got 5 of each of the SO2 and the O2. And this is just initially. Now, we know it's not at equilibrium at this point. But we do know that after a time it will reach equilibrium, and I'm saying that this is what equilibrium might look like. And at this point, you can see we've got 2 greens. Now, how did those 2 greens form? Well, they formed by using 2 reds and a blue. So the reds are the SO2s, the blues are the O2. So 2 reds and a blue. You'll notice that now there's, there's 6 of each here. So there's 2 reds gone and 1 blue. And you can see now we've got 2 greens. So for every set that goes, if it reacts, we lose 2 SO2s and we lose 1 O2 and we form 2 SO3s. So this should be enough to explain why we get minus 2Z, minus Z, and plus 2Z over here. So this is being formed, so that's going to be plus 2Z there, 0 plus 2Z essentially. Does anybody have any questions?
Nope.
Okay. So in the question, we're given, sorry, those should be 1.000 off the top here. I really got to change that at some point. But that should be 1.000 here and 1.000 here. So at equilibrium, it's 1.000 minus 2Z and minus Z and then plus 2Z over here. Now from the question, we're told that at equilibrium, the SO3 concentration is 0.9250 molar. That was here, that was given in the problem. This allows us to calculate Z. So we know that 2Z, since that is the equilibrium concentration of SO3, is going to be 0.9250. So Z here is going to be 0.4625. So now that we've got all of these different concentrations and we know what Z is, then we can figure out what the value of K is by substituting in Z for each of these concentrations. So the SO3 is 2Z, and that's all squared. Then we've got the SO2, that's all squared, and the 1.000 minus Z is the O2. And that's from here as well. Does anybody have any questions so far about where I'm getting any of this stuff from? I haven't explained the significant figures yet, but I'll get to that in a second. Anybody got any questions? Okay. So before subbing in, I think it's always good to work out exactly what each of these things is going to be. So we've got 2Z, and that's all squared. Now we already have that value of 2Z. It's the value of SO3 at equilibrium, which is 0.9250. And that was given. It's given in the problem. So I don't have to figure that out. So the SO2, I know, is 1.000 minus 2Z equals 1.000 minus 2 times 0.9250, sorry, 0.4625. And that should be 0.075. Now let's talk about the significant figures here. When we're dealing with subtractions like this, it always goes by the smallest number of places past the decimal point. Now, since 1.000 has 3 places past the decimal point, then we're going to end up getting 3 places past the decimal in the answer, so it's 0.075. Does anybody have any questions about that?
I have a quick question.
Yeah.
So it's 1.000 minus 2Z. So we're just substituting in that number for Z, not that 2Z number.
You could if you wanted to. It'd be the same thing.
It'd be the same. Okay, so I just wanted to make sure it didn't make a difference.
Nah.
Okay.
But just make sure you're getting the sig figs right there, because that would be 3 places past the decimal minus 4 places past the decimal, which still gives you 3 places past the decimal.
Okay.
Okay, so the SO3, sorry, nope, not the SO3, the O2. is 1.000 minus z minus 0.4625 0.5375 molar. So now you can see how we get the K value, and the K value is going to be just from subbing in all of those different things. So we've got, let's see, so it's going to be SO3 squared, SO2 squared on the bottom, O2 on the bottom. Now the SO3 0.9250 squared, and that's over the SO2 squared, which is 0.075, and that's squared, times 0.5375. And that gives us 280 as our answer. So if you go ahead and you put that in your calculator, you won't get 280 though. Can anybody put that in the calculator? Tell me what they get.
I got 282. Sorry, 282.9.
282.9. Gosh, does anybody want to tell me why I just wrote 280? Is it just because I couldn't be bothered writing the rest of it? Any thoughts?
For significant figures?
Yeah, because the 0.075 has two significant figures. So the answer comes out to two significant figures. The 0 at the end there isn't significant. It's needed because it's a placeholder. The answer couldn't be 28, but it's 280 is what we're getting there.
Why wouldn't you do three, like the 0.075, isn't that 3, not 2?
No, it's 2 because the leading zeros are never significant. Zeros out the front.
Yeah, but what about the 0 after the decimal point? That's not significant either.
Nope. You can write that a different way. You could write a 7.5 times 10 to the negative 2, right?
Okay.
Whoops.
I see now.
Sorry. Hang on. You get it back out of here.
So that's why we wrote it as 280 and not 283, because 283 would be 3 significant figures then.
Yeah, that's right.
Okay.
That's correct. Yeah, just to clarify what you were saying earlier. So I could write 7.075 as 7.5 times 10 to the negative 2, and that's only 2 sig figs. That's how we know those leading zeros aren't significant.
I got it.
Okay.
So for the test, we'd have to make sure we are careful with those so that we get the correct answer, right?
Actually, you don't have to be that careful because it's better if you are, but you actually don't have to be because, well, that's something I really need to add into the test actually. Now that you say it, Gabriella.
Yeah, because I was doing the ungraded copy of the test yesterday, just doing some of the questions, and when I was putting in some of the answers, it was like wrong, but some of them were wrong by a little bit and some were wrong by a good amount, and it was just like I couldn't figure out why, and it was just because of the rounding for the decimal places, so I didn't know how specific it was going to be for the test. So
there's a fair amount of tolerance on these questions. I think it's about 2%.
Okay.
So if you get within 2% of the answer, and it actually won't, the significant figures really won't matter. But what I should do, Gabriella, is I should add in some significant figure questions that cover exactly what I was doing here in the working.
Okay.
But that's for another time, another semester. But I will definitely do it because
Okay.
that's an experience you guys miss out on here. I can't have that. I can't have you missing out on the fun of significant figures for these problems.
Yeah. Yeah. I was just confused because I think on one of the questions I had put like 115.5 or something, and the answer they marked, or it told me it was wrong. So I only got the half point for the unit, but the answer was like 114. So I was like, oh.
Okay. Well, there shouldn't have been a unit here on K anyway.
Yeah, it wasn't for this specific problem.
Oh,
It was
okay.
for
All
a
right.
different one, but
Well, we can talk about that if ever it comes up in the test and you're really close and it's marked you wrong, you've got to tell me so I can go in and look at tolerance. It's possible.
okay.
It's possible I haven't given enough tolerance to the
Okay.
problem. I've tried to be generous with it, but not too generous, you know.
Okay, yeah. Thank you.
Okay. Does anybody have any questions? All right. I've got this worksheet here. Whoops. Come on. There we go. I got this worksheet here. And it's in the, oops, no, not that one. There we go. And it's in the calculation of equilibrium constant folder. And it's this file here, equilibrium constant problems. Okay, I'll enlarge that a little bit if I can. Maybe I can't. All right, let's download it. Okay. So these are the similar kind of problems to the ones we've just been doing, but I wanted to show you another example where, whoops, sorry about that. Dang it, hang on, there we go. I want to show you another example where you were given the equilibrium concentration of a reactant, because that's a little bit different to what we just did. Now I'm on the wrong file here. There we go. So let's see, what's a good one to look at here? Start with that, and all right. So we'll do 2A here. I'll go through that with you. All right. So this is how we handle something like 2A. So we've got our reaction here, 2NO plus Cl2 gives 2NoCl. So we have our start, or our initial, and then we have the equilibrium. And at the beginning, we're always given the beginnings of the reactants here. We've got 0.800 and 0.500. And here we always assume we're starting with zero product, because all we've got is just reactants anyway at the present time. This is the very beginning. Now at the end, we're going to have 0.800 minus 2Z and 0.500 minus 2Z, sorry, minus Z, and then 2Z over here on the product. Does anybody have any questions so far? So we know we can calculate Z now, And we can say that we know that the equilibrium concentration of NO is 0.500. So what that means is that 0.800 minus 2Z equals 0.500. So that means we have to do a little bit of algebra here in order to figure out what Z is. And if we rearrange this a little bit, you'll see it becomes 2Z equals 0.300. Now Z here is going to equal 0.150. Does anybody have any questions? So that's a little bit of a wrinkle. It's a little bit different to what we just looked at. Hang on, let me move this stuff out here. Okay, any questions?
I am confused about one part. Did you just drag the 2Z from the second equation?
Did I just drag the 2Z from the second equation?
You know what? Never mind. I just realized my mistake here.
Oh, okay. All right, anybody have any other questions? So we need to figure out the other things. We're given NO, so these are at equilibrium. And NO is 0.500. The Cl2 is going to be 0.500 minus Z, which is going to be 0.500 minus 0.150, which is going to be 0.350. And the last thing here is the NOCl, which is 2Z, which is 2 times 0.150, which is 0.300. All right. Anybody got any questions? So after that, you'd sub that into the equilibrium constant equation, and you'd end up getting the answer that we have here. So the answers are all given, at least the final answers are. Also, if you look down here, you'll see that everything, all of these are worked problems as well. Every last one of them, right down to the significant figures. All right, does anybody have any questions? Okay, I'm going to do one more of these. One that sort of illustrates this whole significant figures thing quite nicely, really. So we're looking at, let's see which one, C, 3C. Now 3C, we've got 2P plus 5Cl2 gives 2PCl5. We've got our initial or start, it doesn't really matter what you put there, equilibrium. And we're starting with, let's see, P 8.000 and 1.500. and 0 on the product. And then the equilibrium, we're going to have 8.000 minus 2z, 1.500 minus 5z, and then 2z for the product. Anybody have any questions for the setup there? Now we need to calculate the z value first. And we're told at equilibrium that Cl2 is 0.500 molar, 0.5000 molar. So what we know is that 1.500 minus 5z is equal to 0.5000. All right, what I want you to do, I want everybody to do this. And I'm going to set up a little poll here as well. So what I want you to do is figure out and solve for z, please. Solve for z. And while you're doing that, I will be setting up a poll. All right, let me see if I can get this working here. No, I didn't want that. Sorry. End polling here. Got to figure out how to get this question up here. There we go. All right, so here it is. So what's the answer here, folks? Has to be a correct sig figs. See how many people are here? 14. Okay. We're all over the shop here, aren't we? A lot of different opinions about what this is. There we go. So everybody's voted here. All right. Let's have a look. You're gonna love this. So 1.500 minus 0.5000 equals 5. Sorry, yes, 5z. That's fine. So 5z is equal to 1.000. All right, that's what we've got so far. Now, the reason for that is because it goes by the smallest number of places past the decimal. So that's 3 and that's 4. So 1.500 is 3, 0.5000 is 4. So it comes out to 1.000, which is 3 sig figs. And now the z is going to be 0.200 is going to be the correct answer there. Now I know you're looking at that and you're saying, well, hang on, isn't that a multiplication? And it actually isn't. 5z, because 5 is a counting number, it's actually z plus z plus z plus z plus z, so it's an addition, which means it goes by the smallest number of places past the decimal. So z comes out to be 0.200. So there you go. So 23% of you got that right.
So it's counting the 2 and the 2 zeros after the 2.
Yeah, that's right.
Okay.
That's the sig figs. This is something that's not, but this is on me. I really should have included something like this on the test, but I haven't. And I feel really bad about it because I feel like you've been deprived. I feel like you've been deprived. I'm ashamed. I'm ashamed. I am, but I'm going to have to live with that. The rest of it's fairly easy. It's just plugging everything in to get the answer at the end. But that's the main thing I wanted to show you with this one. All right. Does anybody have any questions? Well, let's take a look at some problems here then, and on the test. There we go. All right, so we're looking at calculating K. So this is the kind of problem that you'll be given. And luckily for you, sig figs aren't really something that are part of this problem. I mean, it's probably nice if you get them, but it's not crucial because it's going to be an answer that comes within some sort of tolerance. So let's have a look at this one. This is a good one because it's a little bit different from something we did earlier. It shows you that it can be done with something that only has one reactant as well. But you'll notice in that case, we're only given one concentration then. Okay, so the initial, but I'll do this with the correct. I'll do this with the correct sig figs if I can. So 3A, that's sorry about that. 0.70 minus 3Z. Oops, sorry. Start again. 0.70, and the equilibrium would be 0.70 minus 3Z. The amounts of the products are going to be 0 and 0, and then over here this will be Z and this will be Z for the B and C. I'll stop here for a second. Now the reactants always go down and the products always go up. Does anybody have any questions? Okay. So the 0.70 minus 3Z equals, let's see, what are we given here? It's 0.20 at equilibrium. Because the concentration of A at equilibrium is 0.20 molar. Now 3Z equals 0.50. So Z equals it would be 0.17. And then we can substitute all of that in to our equation there. So what have we got? Yeah. Oh, we got Z, we got Z, we got the A. So it's going to be K equals B C over A cubed. Now B is going to be Z, which is 0.17 times 0.17 over the 0.20 cubed. That was given to us. And that should give us our answer. There's no units on K though. You don't have to put units on K. You could, if I put, does anybody know what unit they'd have for K at the end of this? Maybe you want to guess what unit, if you wanted to put a unit on K, what would it be?
Is it 1 over m?
Yeah, 1 over m.
Or m to the negative 1?
Or m to the negative 1, yeah, same thing. The way we get that would be m times m over m cubed, which is m squared over m cubed, which leads to either one of those. All right, does anybody have any questions?
Yeah. So,
Yeah.
so I put it in the calculator
Mm-hmm.
just because I wanted to write what the answer was, and I got 3.6125.
Mm-hmm.
So as far as putting in the answer,
I put in 3.6.
Okay, that's what I thought.
Stick to two significant figures because that's what you have there.
Okay.
And if, again, you know, obviously if you take this test and actually, I don't know if anybody's even taken it yet. I haven't looked, to be honest. Probably nobody has because we hadn't finished the stuff yet, but some people might have, I suppose. All right. So you can do these again and again and again, practice. The plan is, if you look at the schedule, let's go back to the schedule here. All right. So we're running a little bit behind here because, you know, the rest of today is going to be a review. I was kind of hoping we'd have the whole day for review, but we just won't. But 8 a.m. Thursday, there's no class, and that's when test 2 is due. All right? So there's no class on Thursday, but you've got until the end of Thursday to finish that test. Now you can do a test today if you wanted. You can do the test tomorrow. I think the homework for this is due Wednesday. Not homework, extra credit quizzes, I should say. So the extra credit quizzes close at 11:59 p.m. tomorrow night. And then this test is due on Thursday.
I thought this was test 1, or is it just?
Oh, sorry, it
Okay.
is test 1. I apologize, I'm in the wrong.
Good.
Sorry, there we go. Thank you. Thursday, September 10th. Yeah, no class. Test 1 due today. So no class, all right? There's no Zoom session set up for it either. So if that's the thing, you'll go into the Zoom folder and you'll say, oh, there's no Zoom class today. Why is that? That's not to say I won't be available to answer questions. I will. The other thing is, let's take a, well, in it, you can't see this on the ungraded copy because I didn't include it. There's a box down the bottom of the ungraded copy that allows you to type in calculations. And that would allow you to get partial credit on anything that involves calculation. That would be like, I think specifically it's more for this question here, this question 4, or well, question 4 on the test, or this question we just did, which is about the calculation of equilibrium constant. All the other questions aren't really that calculation intensive, although you could possibly show work for those as well. And yeah, go on.
Are all of the quizzes under each section, are they extra credit or are they just actually for the class?
No, they're extra credit.
Okay.
Alyssa. All the ones that are, all the ones Alyssa's talking about, like the significant figures quiz and the Le Chatelier's principal quiz. And remember, you can always go to your grades section here. I have to go in as a student, see what it looks like for you. So you'll see this. You'll see this is your test 1 grade here. It'll come up. And there's your extra credit quizzes there. So you can always go into grades and see what you've done and what you haven't done. Does anybody have any questions?
Yeah, so then those extra credit quiz points, I know it was like we added them up and then divided it by 2 or something, right?
That's right. Mm-hmm.
And then that number, whatever that is, we add towards our test 1 so we know what we actually got on test 1.
That's right.
Okay.
And, you see this test 1 complete here, Gabriella?
Okay. Yes.
So what happens is that before you take test 1, this actually gives you a running total of what you've got on the extra credit.
Okay.
So there'll be something there. And as long as you haven't taken test 1, that's what it will be, just the extra credit you've done. So that you don't have to do any calculations here. The grade book does it all for you.
Okay.
All right. Any other questions?
Did we ever do activation energy?
Well, we did it in lecture, but it's not on the test.
Okay.
All right. Let me show you where activation energy is. It's in the PowerPoint notes. There we go. So it starts from here, page 18 on the PowerPoint notes, and goes through to page 23. So page 18 to 23. I'm not really going to go over it in class. It's extra credit. It's not on the test, but you do need it for your lab anyway. But it goes through how to do those calculations.
So for when we're calculating K for the reactants,
You're talking
do
about
we only use gas in aqueous situations?
now. I'm not sure what you're talking about here. Which question?
It's sorted by like K and Q when you're taking coefficients and putting them in powers in order to figure out K.
Well, that's all going to be based on concentrations, and those concentrations could be gases or aqueous liquids, I guess. But for the most part, we're talking about gases.
Okay.
All right. Does anybody have any other questions?
Yeah, so as far as going, what's like on specifically going to be on the test, would looking at the quizzes be what's gonna most match up, and then along with the review for the test?
No, it's actually a lot simpler than that. I'll show you. It's just that graded. It's just this one here, this ungraded copy of test 1. The test is going to be exactly the same as that.
Okay, thank you.
All right. So the idea being, if you take this enough times, if you're getting 90% on this closed book, I don't see how you can fail test 1.
Okay.
I just don't see it. Now remember, this is a closed book test. You don't get to use notes. You can use scratch paper. And I am expecting you to show me your area and follow the directions in Onolock to show me your area around you to make sure that you don't have any notes. Some people like to try and tape notes to their computer screen, that kind of stuff. That kind of annoys me. And if I don't, you know, you've got to use a hand mirror to show me that you don't have anything attached there, anything out of range of the camera. I mean, some people try and get clever about it, but they're, you know, it's a closed book test just like it would be in a regular class. I mean, you know, I don't let people use notes in a regular class. And, you know, you actually have the benefit here of taking this test multiple times. And I'm telling you, it's the same test. People in class don't get that benefit. I think you get 2 attempts at this test though.
We get 2 attempts at test 1.
Yes.
Okay.
You don't want 2 attempts?
No, I definitely do. That's great.
Yeah, so it's closed book, but you get 2 attempts. But the thing is, you really should have everything down by the time, you know, you take an ungraded copy test 1 a whole bunch of times before you even touch test 1. And you've taken it so many times closed book that, you know, you're getting 90% consistently. And then, you know, you'll do well on test 1 when you take that. All right, does anybody have any questions? Just general questions at the present time.
Yeah, I have one.
Mm-hmm.
So when we show our notes, you want us to just put it in the little box that it gives us?
Yeah, there's a box at the end. It's not on
Okay.
the ungraded copy because, well, it doesn't really belong there, but it is in the test 1 you take.
Okay. Because my old teacher made us show it to the camera from our paper.
I won't. No, no. It's too. I don't like it. I don't like doing it that way. I will not do it that way.
Okay, and it would provide us with a calculator, right? On the test.
Yeah. I think what I've done in ungraded copy. Let's have a look. See if I've done this or not. I hope I did. I think I did. How'd that happen? Jeez, that's not good. I tell you what, sometimes I feel like I can break anything. Oh, I think it's because I'm in there as a student. That's the problem. Okay, I think I'm out of that now. All right, that would explain that. Yes, I didn't like that at all. Let me see. Do I have? Yeah, see this link up the top here? Onolock calculator. So what I recommend you do, this is to practice, open link in new window and then have it off to the side so you can practice with it.
Okay.
It's not, I don't like the calculator that much, but it does work. And it's better than me having to police people using handheld calculators.
So at the end, we're gonna upload our worked out pieces of paper.
No,
Okay.
no, you won't. No, you'll have to type it in, Alyssa.
Okay.
Into the box.
Okay, gotcha.
Anything it's not everything. It's just what you want considered for extra credit. Oh, sorry, not extra credit, partial credit.
Okay.
So I do give you extra time on the test to do that. More time than you'd have on the original test, I think. But for test 1, there's not that much calculation stuff done, so you shouldn't be too big a deal. All right. Does anybody have any other questions?
Can we review gases, what gas shifts for Le Chatelier's rule?
Okay, we'll get to review in a second. I just want to make sure everybody's okay with the test stuff. But that will be the first thing I'll look at. Any other questions about the test? Okay. So I had a request here. I'm not sure who made it. I can't see from here. I'd have to look at this. No, I don't want to use chat. Let's look at participants here. It doesn't matter. All right. Let's have a look. Here we go. So we're talking about these kinds of questions. Who was asking about these questions here?
I was,
Who is it? I'm sorry, I can't see from here.
me, Alex.
Oh, okay. So is it these kinds of questions here, Alex?
Yeah, they,
Okay.
with
Right.
gases and pressure.
Okay. Well, I think that's mostly something like this one here, number 16. In which direction will the reaction shift if volume is decreased? Okay, so let's have a look. Oops. No, I'm wrong. Sorry. Here we go. So what you would do is I like to draw a little piston here for these problems. See, volume is decreased. That means that the piston's being pushed down. So what's going to happen is that it's going to go to the side with fewer gas molecules. Now, looking at this one here, we have let's see, so four gas on the reactants. We have 7 on the products. So it's going to go towards the reactants because it's got fewer gas molecules. That's a good one. You know, remember, it's only based on gas molecules, not everything else, because gas molecules are the only ones that are going to be affected by pressure.
If it said volume is increased, would that mean it would just go to the product side?
Yeah, to go to the side with more gas molecules. The way you've got to think about it, in the case of where it's decreased, it's almost like the molecules are being crushed together and they want to take up less room. So 4 molecules will take up less room than 7. That's why it goes to that side. All right. Any other questions? All right. Other questions or concerns?
What about, I always get confused when it comes to the units for single reaction orders.
Okay. Now the units for half-lives are always going to be whatever time unit we have in the question. So that shouldn't be a confusion. So that'll always be seconds, I guess, for these. Now for something like this, these are the ones you're talking about. So numbers, let's see, 6 through 8. What I like to do, once I've figured out or I know what the order is, and you do because you're actually told here what the order is. What I like to do is draw a little graph. And there's three graphs we can draw here. So for 0 order, it'll be time, which is in seconds, or hours. Is it hours? Seconds, no, it says seconds, that's right. And then the concentration will be A, and that will be in molar. Now for first order, it's going to be natural log of A against time. And for second order, it's going to be 1 over A against time in seconds. Now, the way that we know those are from this table here, and we can see from the integrated rate laws what each of these y values is going to have to be. A, natural log of A, 1 over A. So there's no guessing there. There's no memory. It's all there given for you. Now, the unit on log of A is nothing, and the unit on 1 over A is going to be 1 over M. Now, in each instance, if it's a straight lines are going to look like this. They're going to be a negative for the 0, negative slope for the first, and a positive slope for the second. And again, we know that from these slopes here, negative k, positive k. And the slope is always change in y, over change in x. So this would be, if we look at the units, molar per second. For this one here, 1 over second. And for this one here, 1 over ms. So it depends on the order as to what the unit's going to be, but you can work it out by doing a little graph and then just plugging in the units using the slope equation. Is that clear? Anybody have any questions?
For significant figures for this question, would we use 2 because of the time of 51 only has 2 significant figures?
No, I don't think so. It would depend on if you were really well. You don't have to worry about significant figures so much again because it's based on a tolerance here. But if I was doing significant figures, since you're asking about it, I'll say. But let's say it was 101 minus 51 over 2.23. Sorry, but no, 2.23 minus 7.65. We're mixing operations here, so this comes out to be, well, essentially 50 dot really, over negative 5.42. So the answer comes out to be 2 significant figures.
Okay.
Yeah, it's mixing operations. You have to get whatever you get from the subtraction first, and then figure it out what you get at the end. All right. Any other questions?
I have one, question 22.
Mm-hmm.
I just need a little brush up on the rates.
22. Okay. All right. So we've got our reaction here. And the first thing we want to do is figure out if the slow step is the first step or not. So is the slow step the first step?
No.
No, it isn't. Now, the reason we know that is because the rate equation has ABC in it. And ABC is not a reactant. So ABC must be made from something. Well, it can't be made just from either one of those, so it has to be made from both. But we'll get to that in a second. So we know that everything has to add up. Oops, sorry about that. So we know everything has to add up to what we have. Okay, so we've got A, B, C give something. We know that that's the slow step, and we know there's something above that we need to form it. So A, B, C is going to have to be formed from AB2 plus BC. Now you can see that that means we've already accounted for these reactants down here. Anything I form here is going to have to, well, we'll see how that goes. Maybe we won't even need the third step. We'll see in a second.
The products would be ABC plus B squared.
Okay, let's have a look. So ABC plus what?
B squared.
Oh, not B squared, B2 you mean, right?
Oh yeah, my bad.
Okay. And you can see here that that means we've got that product there. And all we're looking for is AB plus C, so that's it. That would be the answer. I didn't even need a third step on that one.
I understand it.
All right. Does anybody have any questions about that one? All right. Any other questions? Any other questions about anything else here?
I guess the final one would be calculating Q all the way at the beginning. Not Q, but K.
Calculating, which one are you talking about?
The one we did right before rate equations for single.
I think it was part
reaction.
4. It was one question, calculating K, I think.
Yeah, I think it's 4.
Oh, 4. Okay. All right. That's the one we were just doing earlier today.
Oh no,
Yeah, there it is.
all the way up.
All the way
Question
up.
4.
Okay. Question 4.
No, it was question.
Okay. Oh, question 4 here. Okay. I'm sorry. Okay. What's the? I'll calculate little k, right? Yes. Calculate
Yeah,
little
question
k.
4 right there with
Okay.
a value of K.
All right. So this is actually not as bad as it looks because you actually get a lot of the stuff already. You don't have to actually figure it out. So we know what the we know what everything is here. So it's rate equals K. Now it's M is 0, so it's A to the 0, B to the 1. The rate we're given here is 107 molar per hour is equal to K. Now A to the 0 is 1, and its B to the 1 is going to be 1 here as well, so it's 0.146.
I think that's question 3.
Yeah. Well, this is what he wanted, I think. And then I was going to
Oh,
do the unit.
I
I'll
guess
do the
4.
I'll do the unit as well. But I thought he wanted the actual calculation for K, not just the unit. I could be wrong. Anyway, so K is numerically it's going to be 732, and the units would be hours to the -1 or 1 over h.
Okay.
So if we have like a to the 0 power, we don't have to include it in that second step because anything to the 0 power is 1.
That's right.
Okay.
Yeah, the unit is to 0 power as well, so it becomes 1. So anything to 0 power becomes 1. Now, as far as the units go here, the situation was it's molar per hour over molar. So the hours, sorry, the molars cancel. We end up with per hour, or 1 over hour as the unit. Now, I am going to do the other one there as well for question 4. But, you know, both parts are really for K. So let's look at this one. This one was the value of K, blah, 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 M equals 2, N equals 0. And we're told here that the initial rate is molar per hour. So again, oops, it's a rate equals K A squared B to the 0. So it's going to be molar per hour on this side. It's going to be K molar squared on this side. And this will be molar to the 0, which is just going to be 1 anyway. So K equals molar per hour divided by molar squared, which is going to be m to the negative 1, h to the negative 1, or 1 over mh. And the m to the negative 1 is because it's 1 minus 2. So the answer there, because it's looking for the value of x, would be this, negative 1, not just 1, negative 1. All right, any questions? So remember, this comes from 2 rules here. A to the x times a to the y equals a to the x plus y. And a to the x over a to the y equals a to the x minus y. Okay. Any questions? Okay, other questions? Other questions?
I'm looking through right now just to see if I don't know anything else. All right, I do have one more question.
Mm-hmm.
That would be number 21. For some reason, I don't know, those 2 recent I guess parts are just got me confused. I thought I had them, but no.
All right, well, let's do this one here. 21, this one?
Yeah, 21.
Okay. So what I would do first is figure out what it would be without the charges, and then I would work out the charges at the end. Does anybody want to tell me what the other product would be? Just ignoring charges. Just
AB3.
AB3. Yes, AB3 would be correct. All right, so it's A3B3C plus gives A2C plus AB3. Yeah. Is everybody okay with that? Anybody have any questions? The next thing we'd have to do is look at the total charge on each side. And presently we've got plus on the left side, and we need 1 plus total on the right side. So that makes it AB3 plus. And in the box, you type AB3 plus.
I have a question.
Yeah.
What determines its charge?
Well, it has to balance. Both sides have to balance. So the charge on the left has to equal the charge on the right.
All right.
Why do
Okay.
you On the AB3 and not the A2C.
Because we were told that A2C was neutral
Oh, okay. I see.
in the problem. You can see that there. So the charge, any charge has to be on the AB3.
On the other one that we didn't have. Okay.
Yeah. Is that fair enough?
Yes.
All right. Let's do another one just for kicks. Because I know this kind of problem bothers people. It's one of those things though. Once you get it, you know, you'll be able to teach it to your grandkids. But you know, if you don't get it, then it's going to be something you're saying, oh, you know, that's just something I'm going to blow off on the test. I just don't want you to have to do that. Just say, oh, that's one of life's mysteries. I guess I'll just let that one go. Oh, I like this one. Oh yeah, this one's a good one. All right. A3B3 C2 plus gives A3B C minus plus something. All right. Tell me what it would be just without charges, just what the product would be without charges on it.
B2.
It would be B2. That's correct. I'll stop here for a second. Is everybody okay with it being B2?
Yes.
Without the charge, yes.
Okay, without the charge. All right. Now let's look at what the charge would be. Now, Jack, I'm going to put you on the spot here. Jack, I'm putting you on the spot. All right. So given what I said earlier, that you know the charges on each side have to match, what must the charge on B2 have to be in order to make the charges match?
It'd have to be a positive. But now I need
positive what?
+3?
Yes, +3. The reason for that is because it's 2 plus on the left. That means it has to be total of 2 plus on the right. So +3 minus 1 would be +2. I'm going to drag you all through this by the hair if I have to. Anybody got any questions? You're all okay with that?
Yeah.
Yeah.
Okay, B23 plus is probably what I'd type in the box. All right.
Could you type that into question 21 and see if it's right? Or if they want B2 +3?
No, I think they're all, well, actually, I think both of those would be correct answers. If on the test you write something that's equivalent, you'll see the answer and then you'll be able to write to me and say, hey, Dr. Musgrave, would you correct this? And I'll say, yeah. Right, if it's an issue. If it's an issue. But it shouldn't be, because I think I've got both answers in there. B2 +3 and B2 3 plus. All right, any other questions?
Yeah, so for the questions on the ungraded copy of test ones, I know you talked about the ones involving gases, but for the other word problems, where would I be able to find like examples about that? Because I know you have a couple videos about it, but is there like some type of note thing that I could print out that would have stuff about the word problems? Because those are the questions that I'm having trouble with.
Okay, can you tell me which ones specifically? Are you
Yeah,
talking about like...
Yeah, stuff like question 5.
Okay, let's have a look. Question 5.
Oh.
Not question 5, no.
No, not question 5. Here, let me
No, I think I know what you want. Like this one here, 13.
Yeah, things like that. Yeah.
It's one of those things. You get it by watching the videos, and hopefully you get an understanding of the situation by doing that problem. I don't. There's nothing specific I can give you about it. It's one of those concept things. It's to test that you understand the concept.
Okay. Under what like title would the videos about it?
Right. This would be Introduction to Equilibrium.
Okay.
And the other one, there's only one other one like this, I think. This would be under the rate equations and mechanisms.
Okay.
All right. But, you know, you can always ask, you can always get one-on-one help from me with that kind of stuff too. But, you know, it really is a matter of understanding that concept.
Okay, I'll make sure I watch that video and then I'll ask you if I have questions.
Okay, that's good. All right. Any other questions? All right, we'll leave it there. If I see, if I'm going to have you in lab today, then I'll see you there. And I'll talk to you all later. Good luck on the test. And see how you go.
Thank you.
All
And
right.
just to be
Thank
clear,
you.
if I've already
Thank you.
turned in my lab notebook and it was good, we're not really learning any new material.
No, you don't have
Okay.
to turn up at all.
Okay, thank you.
Okay, see you later. All right. Bye, everybody. Alex, is that you? Do you have anything?